This is the second workshop for COPDESS in 2021, and COPDESS being the Coalition on Publishing Data in the Earth and Space Sciences, but it certainly does have connections to a number of other domains. Today we're talking about software citation, and much of this work comes from the work of a Force 11 working group, and I'll let those two, our co-chairs, actually speak to that. So kicking us off are Daniel Katz. He's from the University of Illinois, Urbana-Champaign, specifically out of their National Center for Supercomputing Applications. And also Chue, who's from the Software Sustainability Institute out of the University of Edinburgh. And I will let them take it from here. Does that sound good? And I do see slides. Do see slides really well. Thank you. And questions, if you could put your questions in the chat, that would be fantastic for everybody online.
Okay, yeah, so we'll go ahead. So I'm Dan, and Neil will be introducing himself in a few slides. Yeah, so we're gonna talk about software citation guidance that we have been putting together, or I guess leading an effort to put together, intended for authors and journals. And as Shelley said, this is really coming out of a Force 11 working group, actually two different Force 11 working groups. So we're going to start off with a poll and then talk about what we have put together, the software citation, kind of why software citation is important and what guidance we have. And then we'll have a panel of experts that Shelley will lead. Bunch of questions after the experts give some initial statements, and then conclusions and another poll. So let me switch to the first poll. Okay, so just to start off with, if you can go to menti.com and put in this number. Afterwards, I'd like to try to see what your opinions are about software citation today. And this is kind of you as a person in this COPDESS community. If this is something that you're skeptical about, you're interested in learning more about it, you're motivated to do something about it, you're working on software citations in some way, or you just don't really know.
I'm sorry, could someone just help me and put that code in the chat?
Maggie, I did. Do you see it?
No. Ah, yes, now I see it. Thank you very much.
Okay.
All right, kind of vaguely curious if that last ball was labeled Maggie. No, maybe not. Maybe that one was. In any case, yeah, okay. No, all right. Sorry. This is like, it's kind of like popcorn, except the popcorn is shooting in from the corner of the screen and ending up in different pots. So it's hard for me to know when when the popcorn is done popping, but maybe it's slowed down. Okay, so this is interesting. We have actually a lot of people working on software citation, which is interesting, and a lot of people motivated, and some people interested, and only one skeptical person we'll try to convince, hopefully, and one unsure person who we'll see what we can do with. All right, let me jump back then to the presentation. Sorry. Seems like technology should be better. Right. So what we're going to try to do is to talk about what the Force 11 Software Citation Implementation Working Group has been doing in order to develop best practices for authors and for journals for software citation. So the group overall has been working for about 2.5 or 3 years. It followed on an earlier group, which developed a set of software citation principles. And so this group initially, and as you can see, there's a bit.ly link on the bottom, which maybe somebody can paste into chat if they want to, which you can go to get to these slides, and then you can click on the links. And also all these slides, plus the poll results, will publish to a DOI on Zenodo after the session. But I didn't want to do that until after we had the poll results. So the Force 11 group then has developed a number of different things, including a set of implementation challenges to software citation, a pair of checklists for paper authors and for software developers. For paper authors, effectively, how to cite software. For software developers, effectively, how to make software citable. A set of best practices for software repositories and for registries, and then some guidance for journals. And what we're really trying to do is to get to a point where citing software just becomes a common practice. And in order for this to happen, really everybody that's involved in this in the system, all the different stakeholders and participants need to have guidance, and they need to have common ways they're doing things. And in particular here, we're going to talk about the guidance that we think is necessary for journals and for editors, for them to provide to authors and then also to provide to reviewers. And so we're going to talk about the different types of software citation and some of the challenges and some of the recommended approaches. So the reason that we're actually doing this is that at this point, for a large fraction of research, the software that's used within that research is its integral as the papers that the work maybe is building on, or the data sets that are also being used in the work, really for facilitating full understanding and dissemination of the research. Over a fairly reasonable period of time, books and journal articles have benefited from and have led to the creation of an infrastructure that really makes them easy to cite. And this has become a key element in the process of research and academic discourse, really across all disciplines. And what we want to get to is the point where software is really cited in the same way as books and journal articles, that we can make use of this infrastructure that's developed and fit software into it. And we take software we mean software very generally. In some cases code, in some cases scripts, in some cases models, notebooks, libraries, kind of almost anything that is that's based on source code, but not necessarily just the source code itself. And the reason for doing this is that actually citing software helps further research, and it provides a means for other researchers to access that software, so that overall we can get proper attribution and credit, which we do similarly to papers and data and other products. We can do better peer review, validation, support better reproducibility by getting people, reviewers or others, able to dig in and actually have access to all the pieces that they need in order to understand the work fully. We want to support collaboration and reuse. And the idea here is that if people are citing your software and you're getting credit for people citing your software, then maybe it'll make it more friendly and more easy to use, and then other people will just contribute to it rather than rewriting it themselves. And similarly, we want to encourage building on the work of others. And so really, citation of software we view as a means to do a number of these things. The other piece of this is that software citation then elevates software to the level of a first-class object within the digitally scholarly ecosystem. And that's consistent with the present-day significance of software. So let me turn it over to Neil at this point.
Thanks very much, Dan. So I'm Neil Chue, and I'm another of the co-chairs of the Software Citation Implementation Working Group. And as we mentioned earlier, this is really about trying to understand how we can provide guidance around software citation for authors and editors primarily. So one of the things that the group has done over the last year and a bit is try to understand how we take the software citation principles, which are a set of general guidelines for how we expect software citation to be understood and to be implemented, and turn them into something which is more actionable. And part of this is creating guidance for authors, guidance for reviewers, and guidance for editors. So what you see on this slide is taken from one of the papers that we'll reference in a couple of slides' time, looking at the different items that we think need to be present in a software citation. And we split these into recommended items and optional items. You'll probably see, if you've started looking through the different elements, that they look very similar to what you might see for a publication, a book or a paper, or indeed a data set. And that's mostly because, as Dan has said, there is this existing scholarly ecosystem of citation, and it makes sense to try and understand how we fit in software citations so that for the people who already have developed systems and infrastructure, it looks quite similar, but for the people who are trying to cite software, it enables them to do it in a way that supports all of the use cases that Dan described previously. So the things that we've recommended as being elements of a software citation include the field of creators, which is similar to the authors of other types of research objects, the title, the publication venue, the date, and an identifier. And so some of these are the same, but some of them are slightly different for software, or maybe interpreted in different ways depending on the type of software. So it's useful to point out some of the differences as well. And when we talk about the creators or the authors of the software, one thing that is often queried around how we do citation of software is how you come up with the list of authors. So a piece of software might have a small number of authors, it might have a large team of people working on it. That authorship changes through time, and it's sometimes the case that the authorship of a piece of software in general is unclear. However, the guidance we're providing is sort of, again, based very much on the way that we look at authorship for other things as well. Authorship of data sets, authorships of kind of papers can often have very long author lists. Authorships of data sets certainly can change over time as we have different versions. So again, here, I think it's about understanding what the people who are creating the software would intend here, and in some cases even citing the project that has created the software if it has a very large list of authors. The title of the software is something that is probably very similar to the way you would cite other things. Here, the only thing to note is that software may change its name slightly more frequently than other types of research objects. But in general, it's easy to identify the name of the software at the time that it is cited and of the version that is cited. One which is a little bit more unusual is the publication venue. So when we talk about other types of research outputs, we'll be talking about the publication venue as being something like the journal where it's being published in. For software, it's a little bit different. It's almost like in most cases, software is self-published, or it's published through a sort of a third-party site, a repository. So in this case, a publication venue generally means the place, the archive or the repository that is providing the persistent identifiers. So this might be something like Figshare or Zenodo, or an institutional repository. The date of the software is, again, the date that's generally associated with the release that's being cited, or if the date is unknown, it may be that you're not able to put in a date. And the identifier is something which ideally is a persistent identifier that resolves the landing page containing descriptive metadata. So it's very similar to a data set as well. So in some cases, this might be a digital object identifier. For instance, if the software is deposited in a repository, but there are other identifiers that may be used for software, including handles, RRIDs, and specialist identifiers for particular disciplines. Can you go on to the next slide, Dan? So as well as these recommended items, there are also some things that we think are useful to be in a citation. So these include the version. So quite often we will have people trying to cite a specific version of a piece of software. This is useful for reproducibility and for credit. And it's often something which you can find out about the software. So for an author, it's relatively easy to find the version of the software, and it should be included if it is available. And also, as part of some citations in some styles, we may have a type. So for instance, in the APA citation style, and I'm going to show some examples of different citations in a few slides' time, there are different ways of identifying the difference between a piece of software or a data set, for instance. The most important thing, I think, though, as part of the citation guidance, is that as an author, you're trying to cite the software directly. So what we're trying to do is encourage direct citation in the same way as we're encouraging citation of data sets. Because this has not been common practice, in many cases, authors of software will also write a publication, an article that describes the software. So it might be a regular paper that includes a description of the software, or it may be a specific software paper. In these cases, our recommendation is that you cite both of these, but you should cite the software. So what you shouldn't be doing is citing just the article instead of the software, because if we're to encourage this practice to be adopted, we need to make sure that software is cited when it is citable. So that's the kind of very basics of the types of software citation elements. And I'll hand back over now to Dan to talk about how we're trying to get adoption around this guidance.
Great, thank you. So yeah, so we've done a couple of different things that I'll talk about on 2 slides. One is that we published a paper in F1000 Research that basically provides a bunch of the guidance that Neil has just described. And it's worth mentioning that we really strove to include a large number of publishers here. And so the bottom half of the slide actually is a screenshot of the competing interest section of the PDF of the paper. And what it says is that we have representatives and editors from some journals that are specializing in software, plus some very general journals in astronomy and geoscience and cross-discipline and so forth. So yeah, so we've tried to include lots of different publishers in this, and in addition to that, we also are in the process now of building something that we're going to call a software policies index. And this is something that will be published by Chorus. Chorus currently publishes a data availability policies index. And the URL for this is on kind of in the middle of the slide, and there's a picture of it as well. So effectively, the data availability policy index says for each of the publishers, what does their data availability policy say? Where is it? We're going to do something very similar to this for software policies. And we have a draft of this page now, but it's pretty limited. It has something, I don't know, 7 or 8, I would guess, policies at this point. So we're trying to add more policies to this before we publish it. And if you're interested in this and you have any policy that is in place now, or you're developing a policy and you want to put a draft of it, please let us know. And we'd like to add some more policies to the software policies index before we publish it. Once we publish it, we hope that it'll be used as a kind of informal peer pressure in some sense between publishers, and something that maybe authors also will look at and then try to see How do they kind of, what's the best place to be publishing things, and how are they going to put in citation information in some way, and how's that going to compare from one publisher to another? All right, back to Neil.
Okay, so finally, just before we move on to the panel and to kind of give you an idea of how this might look in practice, this slide includes a few different examples of how we might see software citations in the wild. In this case, what I've done is I have taken extracts lightly modified from papers in a number of different journals, including I think it's Computational Geosciences, Geosciences Model Development, and JGR Biogeosciences to kind of lead us into the discussion with the editors that we'll be having on the panel that comes up next. In general, most software citations appear in one of two types of sections. The related work section, where people are trying to describe other approaches to doing the same work and are perhaps comparing the way that different methods that involve software take place in that domain, and also in the methodology section, where software is being used to produce the research results that are being presented in the paper where the software is being cited. And so what I've tried to do is provide examples of a number of different types of software citation, including some that follow the guidance that we've presented and drafted to the letter, so what we might call an ideal citation, and also some which represent things which are also software citations, but maybe don't follow all of the recommendations and give you some reasons for why it becomes harder to do some sorts of software citation. So the first thing I'm going to look at is actually the second in that list of references. So this is the one for the Advanced Terrestrial Simulator. And so this is an example of what we might consider an ideal software citation. So here it's being referenced in the first of the examples in the methodology section, and it's in this case the piece of software that's being used to do a particular part of the research. The software itself has been deposited in a digital repository, in this case Zenodo, along with, so that's given it an identifier along with a version, which is also included in the title. This particular piece of software is a real piece of software, and it has, in fact, all of the examples are real pieces of software. And as you can see from the ... in the APA style, it had a very long list of authors, but in this case, they're all listed as part of the information and metadata that's present in the repository. So here, the list of authors is all included by the authors of the software in the repository metadata. So that's an example of something which is effectively an ideal citation. It provides all of the information that we recommend, and in this case, all of the information was available to the author through the metadata that was provided in the repository. An example of something which is, again, quite easy for an author to work with is the second one in the methodology section, where the author is describing the use of someone else's software, in this case, a particular piece of functionality that's part of the core R package, R programming language. And in this case, it's quite easy for the author, because here the R project provides a recommended citation. And in this case, the recommended citation is to the R project itself. Now, it's easy for the author, but in this case, it's perhaps not quite as ideal as the previous citation, because this is not directly citing the software. It's sort of going to an intermediate landing page. In some sense, the R project itself is acting as the landing page for this software. So this means it's a bit less machine readable. The metadata might be harder to find, but it is still an example of a software citation using a recommended citation. It's not to a paper or some other proxy like that. Similar to that, the first example is to something called BLAS, which is a set of mathematical libraries that are used quite often. And here what we can see is an example in APA style of how to cite what we might call a software concept. So in most cases, we'll be seeing authors cite particular versions of a piece of software. But in some cases, particularly in related work sections, we might not be referring to a particular version, we might be referring to a collection of versions. So here we have this idea of a software concept, which is all of the software that has the same sort of functionality. So it's a set of different versions being referred to as one single concept. And this is the sort of citation that's used here. Again, here, this is not a perfect citation because it is something which is pointing to a website, but there are increasingly in repositories support for software concepts so that you may be able to cite all versions of a piece of software that has been deposited in a repository. And then finally, the last one I wanted to highlight is the second in the related work section. And here, what's being described is a reference to a piece of commercial software that's being used to calculate a particular sort of type of mathematical technique, so finite element methods. And in this case, even though it's a commercial software, it can still be cited. In this case, the challenge here is that there isn't necessarily a date associated with software, and there's very little information provided on the web page for the software producers. So here, this is an example of something where perhaps it's not an ideal citation because it's relatively hard for the author and for the editor to check whether this is providing useful information. But in all of these cases, I think the main thing is that what it shows is that there are many different ways in which we can provide support to help authors cite software. And I think one of the key things is providing guidance within the journal's own policies for authors to help them understand what's being expected of them when they submit a paper or an article. And what I'm going to do now is hand over to Shelley and a wonderful panel of journal editors to talk a little bit more about the various challenges of putting this into practice from the journal's perspective.
Thank you, Neil. So two of our editors, production operation as well, Melissa and Gus have both been part of the Force 11 group, but Ankur Desai has a really interesting viewpoint and is going to kick off our panel discussion. So Ankur comes from University of Wisconsin-Madison and specific to the Department of Atmospheric and Oceanic Sciences. And for AGU, he's the editor and one of our editors for JGR Biogeosciences. And then for the American Meteorological Society, Ankur is the commissioner for the Scientific and Technological Activities Commission. So this makes his viewpoint really very interesting. Melissa Harrison comes to us from eLife, chair of the JATS group, which is the schema that's used within many publishers, specifically for reuse. That's the R, reusability, and also very helpfully part of the Crossref community as their part of their board of directors. And then Gus has been really critical in helping us understand software citation as our authors coming to the American Astronomical Society and really navigating through all of the different challenges that we needed to consider with all of this guidance. And then there's a project working on credit the Asclepias. So this project team that he's part of, I'm not even going to try to say it anymore. So I'm delighted. Let's start with Ankur, and then if you could just put your questions in the chat as we're going, we'll get to them on the other side of the panel presentations. Go ahead, Ankur.
Thank you, Shelley, for having me, and just ping me if there's any issue of audio. Thank you for those attending, and appreciate an opportunity. As Shelley said, I hope I'll try to be interesting, and if not, ask me some harder questions. So folks here, I think a lot of you, as we heard in the presentation, are really good at crafting guidance and infrastructure, developing policy, and all of that's really important. But I'd like to talk a little bit more about what's harder to change, which is the culture itself, right? And the culture change here being the idea that data and algorithm preservation and reuse are just as important as the publication and research products we make through that. And until that perspective is there, broadly along the sciences, that the perception will continue that this is mostly an extra burden. And so I'm not a cultural anthropologist. Maybe I should have been one, but I'm just a scientist who runs a lab, and I contribute in a few places, as Shelley introduced, the community. So what I'd like to do is just share a couple examples, and hopefully that will spark some discussion. So I'll share two examples, one on data and one on software. So for data, the journal I edit, so we were early adopters in the data standard at AGU, and we actually started a policy of rejecting papers without review for lacking fair data links. And we actually got quite a bit of pushback early on. And we spent a lot of time learning about repositories, providing advice, writing short articles for authors. And it became clear as what kind of might be obvious to a lot of the folks on a call like here isn't always clear to scientists in their day-to-day going on. We saw a lot of hurdles with very specific types of data, particularly in the things that were very small but very important, and things that were very, very big. And also differences across institutions and countries. And one thing I learned from that experience being an editor for now 5 years was to be flexible and appreciate good faith efforts, that if we made strict barriers, lots of requirements, while it might lead to more uniformity, what it really does first is privilege certain labs over others, in particular those that are well-resourced, which tend to skew towards certain types of institutions, career stages, locations, and to shut out others. Our hardline rejection policies in some ways discouraged papers that we really wanted. And we learned to get around that to develop data-specific decision letters, journal-specific data guidance that built on AGU's data guidance, discussions at editorial board meetings, and more options for sharing data that maybe is not in the proper way, but at least something that works during your peer review phase. And the other thing we saw at the same time was a lot of innovation from early career scientists. And often the best data management examples I saw were like posted in social media, and we tried to kind of highlight some of those. It taught me to keep an open mind, to meet authors where they're at. Not every paper we publish is going to be perfect, fair in the way that maybe is spelled out in the principles here, but the more we do it, the more it becomes part of the way we do our work. And often the early career style researchers, once they become established, they will impart that culture. As Max Planck is often summarized to say, science advances one funeral at a time. This is probably a bit true for open science culture too. My second example comes from the disciplinary society I'm currently volunteering with, where we're trying to come up, a board that is underneath me is trying to come up with a statement on software citation and archiving based on the principles here. And here I think the rate of change is going to be similar to what we saw in data, but perhaps with some new or different types of resistance, right? Observations have always been the bedrock of science. So the culture of curating, careful documentation, backup of data kind of has a longer history, which makes sharing of data perhaps a little more straightforward. You can't do any science without data. However, software is a later entrance or an evolution of our protocols, methods, statistics. After all, unlike sloppy data, you can do science with sloppy algorithms. And that I think is making people more cautious about software fair principles. The culture has more to catch up on practices and terminology, licenses, repositories, all these concepts I think are much more foreign. And often when I hear somebody like Shelley or others present things, I'm often Googling myself half the acronyms that a lot of you throw out, even though I'm somebody who's paying attention to a lot of these things. What we saw in the second case was that attempts to craft a statement on software led to a lot of questions on its need and what it obligated the society's journals to do, and whether they were ready to do that before their peers were, and to what extent individuals felt comfortable sharing the typical levels of messy code that scientists like to write. We write a lot of software. We write short artisanal snippets written on the command line by one person, and other times complex models written by large teams. What obligations does one have to all of these? The definition of software might be almost too broad to fit one standard. What kind of support has to occur if software is placed out in the open? How much more commenting is going to be necessary? Who gets credit in a large model? Do I have to version every little software snippet I write? These are the types of questions we were getting. Software is also a stronger statement of intellectual property than data, and that involves the creative application of math and visualization to theory and data. Observations or nature are out there for anyone to collect, but the right tools and protocols. Maybe a satellite's a little bit beyond your budget, but software is different. It's a creative spark, which turns observations and numerical solutions into tests or theories, which is what separates science, say, from stamp collecting. So I can see people having a harder time. In the end, it's a good thing. It's not going to be solved by policy alone. The best practices are coming, again, in software from early career scientists, and we should be inclusive of creative solutions. And like in data, a culture change requires recognition that access to tools and abilities is unequal, that just because someone doesn't want to share doesn't mean they're not open. There may be multiple reasons, the most common being time and effort relative to perceived reward. Slow change is better than no change. And so maybe we need more guidance on how to adopt best practices, some sort of coordinated action to prevent resistance to be the first mover among journals and societies. After all, peer review in our modern way of publication is also recent innovation. Even Einstein railed against peer review in the early part of the 20th century since it was against the culture at the time. In that case, a fear of being scooped when papers took months to send in the mail. Eventually, it became to be the norm as the risks of being scooped were outweighed by the benefits of having external evaluation of scientific rigor. So I think as the benefits of open science become more apparent and more junior colleagues start to run their own labs and develop a culture of practice, change will come. That's how it always does. I think I'll stop there.
Thank you, Ankur. That was fantastic. I can't wait to see all the questions. I know they're getting written right now. Melissa, do you want to go ahead? I think you have slides. Yeah, there we go.
Yeah, I do. Thank you. Thank you for the invite to come and talk. I'm slightly nervous. I'm glad that you pointed out, Shelley, that I'm in production. I'm not an editor. So if we could have the next slide down, please. So yeah, crazy picture of me. I just wanted to explain, I'm not a scientist. It's been 20 years since I did my undergraduate degree. I don't understand code and things like that, and my kind of skill and expertise is in operations and workflow, and my entry into the open science arena is via working in groups like the Force 11 group and things like that. So eLife, its main aim is to improve research communication through open source, open science and open technology innovation. We're a non-profit, mission-driven. And there are three major areas that we work within, and the one that I'm going to focus on is publishing, and we publish in the life sciences and medicine. So it's kind of very general, broad-based journal in that sense. If I could have the next slide, thank you. So in our author guide, there has been a big focus on data and the methods used and materials. And the idea is that everything should be clear and precisely documented to maximize reproducing and replication of the procedure and the results. So reproducibility is a big focus there. So as a result of that we ask authors to provide program codes, scripts for statistical packages and other documentation so that somebody else could reproduce the results. And there are three main tracks that we ask for that in, but if we could just go to the next slide. In our author guide, the software section, so is that we ask that authors should license their code using an open source license. So again, it can be reused and built upon, which is how we see the scientific endeavor anyway. We now, it's been relatively recently that we now any code that we have is it's put in the archive, which is software heritage. So that's slightly different to what a lot of other publishers have gone down the route of. So I'll explain a little bit more about that. And we also ask that software is included as a reference and cited in the article. And so my experience of working on data, which came kind of before software in all of in these sorts of areas, is the idea for kind of credit and the need for things to be cited in the reference list. So something I discovered through my work with JATS4R is that places like Google Scholar, unless something is cited in the reference list, it doesn't get picked up, and so the credit doesn't go forward. So even if you tag up your content beautifully, so these things are included as a reference but not in the reference list, it doesn't get counted. So there's a lot of complexity in the way that publishing has developed, as it was referred to, kind of alluded to earlier about books and journals, and trying to shoehorn software and data into these old archaic systems that have been around for years can be problematic. But anyway, if we could go to the next slide, please. So with regards to software, the editors and reviewers, they do comment on data and code as part of their review. They're not obliged to. So the main focus that has been at eLife has been the editorial and production staff. So staff will consult with editors, you know, if there are questions around the availability come up, if they found something in the paper and they think it should be open and the authors are reticent, then they will consult with the editors for their opinion. The biggest issue is around consistency, because not every editor or reviewer treats the content in the same way, and the software, and likewise some of the processes, which I'll explain a little bit further on, within the workflows aren't always that consistent either. But as Ankur mentioned, it's a work in progress, and I think that's the thing, you've got to start somewhere and build upon it. So the editorial staff, at the stage that they've got of the workflow, they're just dealing with Word files. So they have kind of simple scripts where they search for certain keywords within the text, for code and software, and they'll check if it's in the reference list, and if it's been generated for the paper, they'll check whether it's opened and licensed. But you know, some of these do get missed because it's not that fully automated. So in production, it's in a structured format now, and we can automate some of the earlier checks and pick up some things that were missed earlier, or if author made changes during the process. We also archive code in software heritage, and we ensure that software is cited and referenced semantically. One of the things I would say is that earlier on today, I was looking for some examples to put in here, and I came across at least 2 articles that have been published recently where things hadn't been done properly. So again, hats off, you know, this happens, and this is all still relatively new. And the editorial staff and the production staff, like me, we're not experts in the field. We're not editors, but we're doing what we can with the knowledge we have. So if we could, next slide. So the first thing to talk about is the open source license. So if we could go on to the next slide. So as I said, the editorial checks, they do searches within the article for key things like on request, upon request, available, and also for software keywords that they might find. And during the editorial process, so we have initial submissions and we have revised submissions, there are letters that go out to the authors at each stage, and they'll add in boiler text requests regarding these sorts of problems, along with anything else they might pick up. It's pretty intensive what the editorial team do, trying to support our, open science and all of the things that eLife is supporting. So the common issues that we find is that the authors have deposited and licensed the code on somewhere like GitHub, but there's no reference in the reference list. Or authors have code on GitHub, but it's not licensed, and that's very key. Is that if it's not licensed for reuse, then people can't build upon it. And like I said, it's a manual process, and sometimes things have been and can be missed. But in the life sciences and at eLife, we have a key resources table, and so the authors are asked to publish that with their content, and it's the beginning of the methods. And it's designed to highlight all the resources that are used. So software are presented within that table, and that helps us in some ways kind of pick up things later. So the next slide. So we, like I said, we recently moved to software heritage as an archiving place for any code that we find that's associated with the article. So if we go to the next slide. So our previous solution, we've always felt strongly that that code needs to be saved and it needs to be accessible afterwards. And so we had a dedicated GitHub repo where we forked the code to, and we required the code to be licensed before forking. which was problematic for the production team, because it was our job to do it, and if the code wasn't licensed, it held things up, and sometimes it's like the need for the citation and for the code to be linked properly within the text is probably one of those kind of starting places that's more important for us right now than the licensing. And also it was inconvenient for code that wasn't already on GitHub. And the key thing is that there's no persistent identifier on GitHub. Now, I've talked many a time on the Force 11 groups with Neil and Dan about this. I couldn't get my head around it in a way, because GitHub, it has the little strings and the commit codes. But the problem with GitHub is the fact that it's not an open place, and it could go away. So we now use Software Heritage, and it's a different choice than a lot of publishers might have. A lot of publishers went for the kind of Zenodo route, where the author, there are good links between GitHub and Zenodo, but only the author can do it. And they get a DOI, and then that can go in the reference list, and that can be the citation point. Now, we had some resistance from within eLife, from the kind of non-publishing background people, saying DOI is very publisher focused, and they really loved the idea of the software heritage system, because it kind of replicates how it looks in GitHub. And the other thing is that because it's constantly going through GitHub repeatedly, like maybe every 6 months or so, any updates to that code will be still part of the link that we provide within the article, and it's a software heritage ID. So there have been some benefits, and also there is an API and there's some automation, and so it's really helped us speed up our process, and also allowed staff to do a bit more within the process than we did before. So if we could go to the next slide. So Shelley asked me to kind of explain a little bit some of the challenges. So as the same with forking our code, we had to train our vendors to follow new procedures, and training people to do things, it can be hard, but we've got there. The software heritage IDs are very, very long. And so that does kind of take up space in the article, and we're looking for different solutions around there. And the processing time can be quite long for large repos. But the benefits are that we're using PIDs now. There's no loss of version history, as I mentioned. We can validate the URLs to make sure they're correct using the automated processes we have within production. It's less manual for us, and the fact if code isn't licensed yet, it is less of a barrier to us. And eLife has invested a lot in a new open source software, our archive executable research articles, and we're looking to be able to archive them in software heritage as well. So I think I have another couple of slides. So next slide. So cited and referenced. So if we could go to the next slide. So we, in production, like I said, the content's in a structured format now. So we have lots of QC and instructions, but also some automated things that are checking for the content to make sure that software is cited properly. So for instance, if GitHub is mentioned in the article, that there is a reference. On the right, I have an example of our key resources table. So I don't know how well people can see, but it lists out all the different things. And this is an example that I found where it had, software algorithms. There are 5 citations there. They're all in the reference list, and recent work on our website has indicated, if it's tagged as a software reference, then that becomes clearer. And there is an example here that the bottom reference on the left is to a research article. So again, I think as Ankur, no, I can't remember, it might have been Neil was talking about, please don't cite the paper, that please cite the software itself. We do have some resistance in there, and we are pushing back, but it's definitely a work in progress. And we've got a lot of automated checks and things like that. and QC and instructions for the staff and for vendors, but still sometimes things slip through. But if we go to the next slide, I can show we're doing well. So since we started publications in 2012, the VOR publication, so that's the version of record, the final version that's published. You can see right at the beginning, we weren't indicating and pulling out software references at all. In February 2017, we introduced tagging rules for the references. So we had some sort of validation process that was helping. So the software references, so that's the actual references in the reference list, and software citations are the citations within the text to that. And as I pointed out, in May 2019, we introduced the tagging rules, and they've been worked on ever since. So we have a dedicated person in-house who's constantly reviewing things and constantly increasing the queries and the questions whenever something goes wrong. And I mean, it's great to see, you know, publications. The big dip is because we're not that far through the year so far, but we're seeing that they're all converging together. So there's a much less distance between these things. So we're seeing this as a success. So I think that's my last slide. I hope I haven't gone too far over, and thank you very much.
Thank you so much, Melissa. That was fantastic. It's good for everyone to see that when it gets to the publication side, it is hard. And to drive that message home, I expect we will hear similar and even more coming from Gus.
Well, thank you again for having me on this panel. As was mentioned, my name is Gus Muench. I am a data editor with the Journals of the American Astronomical Society. And let me find my slides. And so what I'm hoping to do today is to talk about so you've heard, you know, sort of conceptual pieces around publishing and articles and software, and sort of what I really enjoy hearing Melissa's end-to-end perspective and experiences across the production and development of a journal. And I'm going to talk a little bit more narrowly about our experience working with authors during the peer review process. So I had thoughts of talking about, like, sort of, you know, the issues that come up when we do all this work, and I'm gonna say this at the end too, to try to improve the citation of software, and then have it sort of fail at the end of the process. Like, we look at our outcomes and like, oh, well, you know, this didn't exactly come out the way that we had hoped. But instead, I'm going to focus on that author piece. You may have heard mention of the Asclepias project, Asclepias being the genus of the milkweed plant. The reason why that name was given to it is because if you ever look at the flowers of the milkweed, there's a continuous, sort of really complicated forking structure. And we thought that would be a good mirroring of the problem of trying to track software citation as projects evolve. And they evolve in ways that are not exactly typified by GitHub, right? They fork in ways that are abnormal and sometimes dire and problematic. But we received funding. So we, as a group of institutions, the Journals of the American Astronomical Society, NASA ADS. So ADS is the Astrophysics Data System, but it refers to the indexing of research objects, not about data. So it is, we don't go to Web of Science, we don't go to other tools like that. Astronomers go to NASA ADS to find articles. And then CERN Zenodo was the repository that we work with. So we're responsible for things like concept DOIs in Zenodo, versions in Zenodo, and the indexing of software citations in astronomy, and changes to that workflow to try to adjust the infrastructure for how software citation is being done. And I know, like, having heard everyone else talk before, I know that what I'm going to say is going to be a little bit of a hard break And I'm okay with that because I recognize that what we've been doing for the past 5 years has been with one goal, and that a lot of things that you just heard about reproducibility is a different goal. And there was a really great comment about maybe they're different, right? Maybe what we do for citation, for attribution, and what we do for reproducibility are different. And I can't agree more that it feels like there's a constant orthogonal tension there. And maybe we created that tension and it's our fault, and you can blame me later. So the topics I wanted to go over are the thing that started the work that I'm going to talk about was a policy change in 2016 that our journals decided to make. And it did so for a few reasons, none of which are really about reproducibility. I want to talk a little about who the data editors are, and that's not to toot our horn, but to sort of say this is where we stand in this process. So these are the things that we see in terms of author behavior. And then a little bit about how that maps into models for software review and citation. And sort of to understand how we're trying to go, not necessarily evolve from talking about attribution to reproducibility, but to talk about different modes of attribution, and what you let go of necessarily when you pick a different model for citation. So you don't have to read this. It basically says software is critical to research, and it should be cited in some form. And you should software in an open source license. And it gives sort of an outline. Let me zoom in a little bit and focus on the things that it was trying to do. The focus is on attribution, right? So there were a number of us who had worked in the virtual observatory or had worked in a group called Dot Astronomy. So if you go to dotastronomy.com, and we've been talking for years about the problem where there were lots of software developers in astronomy doing really amazing things and getting absolutely no credit whatsoever for it. And so this entire policy was about changing that, right? Changing the ethos of attribution for software. So we wanted to increase that. Citation is about attribution and about recognition for software developers. We had to deal with a historical problem. In the late 60s, there was this editorial written, it's untagged, but we believe it was written by some of the really big names in astronomy, that said computational work is unrelated. Discussion of computational work is not part of the scholarly corpus. It's people in computational research and software do their work over there and not in the research corpus. So we had to tear that out. And then we needed to sort of try to give our authors tools for preserving and citing software in manuscripts. So again, this is just a bunch of text. But one of the things I want to highlight is that in this original policy, we could see that there's an attribution problem. Like, how do you create something that can be cited and recognized and has the same value as a paper, right? In an index about papers, how do you make the two things look similar? But then how do you directly cite the software so that someone can follow that citation and get to some version of the software that they used? And so we knew that there's a little bit of tension there, but we went forward with the attribution focused model. So some of the tools that we tried to give authors, we still don't have a data availability statement in our journals, but we have a software availability statement, and it's not even a statement. It's a contextual list of software used and a citation for that software. And again, the model, if you look at these DOIs and you know anything about DOI structures, you know these are journal articles about software. Cite an object, a preferred citation for a piece of software so that the developers of that software receive credit for that software. So we gave them, we introduced the GitHub to Zenodo workflow. If you have software or you're creating software, please create a version and cite it. We created BibTeX styles that encode all the features that Neil went over in terms of the guidance, with the exception of the software tagging, version, publisher. We gave those to authors and said, do this, right? And if you do this, the citations will be in the reference list and someone will get credit for them. So that's sort of the framework, attribution-oriented framework that we took on in 2016. And this is how we tried to push that along. So in our system, we have two data editors. I'm one of them. I've been doing this for about 7 years. And then we have another data editor who's been doing it for 21 years. When the journals went digital, we hired someone to deal with all the digital data that came along with digital articles. And so this review, the work that we do is not just on software, but I'm going to try to emphasize the software-related things. So what you see on your screen is an automated, the light blue tag is an automated tag where we have a script in the submission portal that walks through the text of an article and looks for things that look like software. And the darker blue thing is a review that we write at submission for about 90% of the manuscripts, where we ask authors to do something with the code that they are that they create. So this is code or software created in an article and mentioned in that article. So if they don't mention it, we don't really deal with it. We'll come back to that later. So we look for mentions, so words that refer to software with no citation. We go and look those up. We give them to the author and say, please cite the software this way. And then we look for the mentions of their code and ask that to be preserved and then cited in the text. So that's at the beginning of the process. And these are just some more examples, but the number of anecdotal examples that come out of looking at this stuff is not few, right? So in the bottom example, right, there was a code that said, we use the modified version, period, right? And it's like, no, we need to do a little bit more here to give some attribution and also to release your code, because it wasn't clear that, like, what did they change, right? What's actually happening with the code base? Because it's not, if we were all in a GitHub org and A forked B and we could just follow the dependency chain back, that'd be great. But that's not what, especially with older codes, that's not what happens, right? It gets just copied and then changed. So we try to deal with that at the beginning of the process so that then this information can be given to the authors of the text to fix during peer review. So then we look at the papers again, not all 90%. We look at about 15 to 20% of those manuscripts at the end of the process and sort of check, did they do what we asked them to do? How well did they do it? Are they using the right tools? And so we sort of repeat the process, but not for all articles, but for a subset that contain data. So it's sort of like if you have an article that contains a lot of data or software, you're going to get reviewed twice, like multiple times, which maybe that's just refining things that are good into things that are better. I don't know if the conveners of this panel intended me to talk about this, but I want to talk about it briefly because it goes to the problem that we were trying to solve in an attribution-oriented workflow, right? So what is it that people should cite, right? And there are three kind of things that we end up recommending for people to cite. Maybe we're upside down, but we begin with like a journal type article or a journal-like citation. We have examples in astronomy of code libraries where people can essentially say, I have this piece of software, it lives over here. And this is the metadata about that piece of software. And it's static. I'll talk in a second about some of the examples. And then the last one is direct citation of software by version and release. So what is this, like, journal articles about software? What are these proxies? So one of the best is the Astronomical project. So they published two papers, one in 2013 and one in 2018, thousands and thousands of citations, not a majority, but a large number of articles that I see use Astronomical as a fundamental base. And they had version 1 paper and version 2 paper. And they may have had 25 or actually it's about 55 versions, tagged versions of code that have been released, direct versions that could be cited directly, but two major papers that accumulate all the credit. And in their world, right, the author list of the first was augmented by having a second author list of the second version, which expanded the number of people who have contributed and captured at that moment in time. It's been 3 years. I'm sure that there are tens of dozens of other individuals who are working on this project who are not necessarily receiving credit using these proxies. But the nice thing is they give very clear examples. Please do it. Please acknowledge our project this way. Another example that I wanted to talk about are the Journal of Open Source Software. These are articles or journal-like articles which review Dan, you can correct me afterwards if I'm using the wrong terms, that we view directly the code. We encourage citation pseudos, especially if authors, developers of that code wish that to be cited, right? So we're trying to figure out what they want, which we'll come back to in a second. And I also wanted to mention that we engaged in a project that for about the past 2 years or so, about 20 articles where there've been there's actually a research article that has a significant piece of software, and the research article is reviewed by the journals, by a science editor with a science review, and then the software is reviewed via JOS as 2 separate articles, which then link together, and then presumably the author of that of those articles would like them both to be cited. Another thing that we do is, and this has uptake. In other words, this code library is not simply a code index. The astrophysics source code library is not simply it's curated by an individuals that find all the software being used in astronomy, try to craft metadata about that material, and then that's indexed in our research article index, the ADS, and then people can cite those entries as well. That's not to say these are IDs that a curator created and then people are citing them. We kind of work with authors of papers to say, well, what did the developer want you to cite? And we direct them there. But there are a significant number of developers of code who are like, I think this is great. I'm going to suggest people cite this entry. I'm going to maintain the metadata in that entry. If I have a new author, I'll just change it, right? If I give the project to somebody else, then they'll just change the metadata for that software. But this is something that's actively being, it's something that's embraced by a large number of developers in astronomy. But there's no versioning, there's no metadata versioning. We can talk about that too, right? That's a scary topic. And then we come to another thing that we're trying to help in terms of attribution, which is the direct citation of software. So the main one that the Asclepias project worked on was citation of software by DOI, right? So blame us. The idea was that if you go and you go to CRAN or PyPy, you download data by version, or software by version. There's a version 5, and I'm going to use that version of software. And the idea was, well, let's just map that to the DOI system and ask the authors to create the metadata about that object. And that's been a frustrating process. I mean, what it allows you to do is to create a citable object that's by version. So if version 1 had 2 authors and version 10 had 15 authors, that digital object is accumulating for attribution purposes the authors of those objects. It requires people to behave in different ways, but explicitly stating who's the author on a project, maybe that's explicitly different too. I'm sorry for the background noise. I apologize. So that's what we did. That's what we've been pushing authors to do this, and you get a variety of uptakes in terms of how well the developers curate their metadata or not. But if they curate and they create a citable version of their software, and that version is cited, then it appears in the overall scholarly index from astronomy. And then the last one, I've been using up a lot of time, and I think there's a lot of questions we should get to, is the role of software heritage. So in 2016, we had a sense of code libraries, we had a sense of DOIs and of journal articles, but we didn't have a sense that something like software heritage was going to exist. And when we take what we've learned about indexing software and citing software, we're not really sure what to do with it, right? We're at a stage where we're considering changing our policy to say that people can cite software heritage. But when you do that, you're faced with sort of the same problem that you had a second earlier with the DOIs. Who are the authors? Where would you solicit that information in order to achieve some kind of attribution? So this is where it feels like in the story it's forking, right? If we want people to be precise and enable reproducibility, then absolutely. If I was running a reproducible journal top to bottom, I would be building out a reference model for software heritage. But that's a different goal than trying to achieve attribution for authors. So again, I think that's the end. Oh, well, so these are the things that we struggle with in our experiences. There's often no preferred citation. So what do? If something hasn't been cited yet, it's not going to be indexed, right? It could be indexed, but there's a whole other conversation about what you index in a scholarly index and what you don't. Authors, developers, especially if they want a package reused, tag and version things all the time. But a minority of those actually curate the metadata with care. So it seems like there's a little bit of a not huge disconnect. There's all kinds of anecdotes about authorship that I could share. And of course, then the final frustration is the one that I mentioned at the beginning, that we do our best with authors to help them cite other developers' software, but then things go wrong in the final article and it's out of our control in our system. So I'm gonna stop there and so that we can get to some of the questions.
Gus, thanks so much. And I think between Dan and Neil and our panelists, the folks that are participating live and those that'll watch the recording later can understand this is really complicated and the number of challenges are great. So we had a few questions throughout the talk. I know Maggie had to step away, but she's very keen to watch our recording later and let me know before she left. And she did have one of our first questions, and I believe it had to do with creation and authorship. And Neil, did you have additional comment? I think she directed it towards you.
Yeah, and there's been some discussion of it in the chat for this meeting, which hopefully will also be made available to people. I think one of the challenges here is around where that kind of additional granularity around authorship and credit should be presented. I would argue that a citation is a very coarse way of trying to identify the many roles that are part of giving credit for a work that you are referencing. And as Dan noted, it can be hard enough just making sure that you get who should be the authors correct and not just what they contributed. So I think there is a role in this in the scholarly ecosystem. I note that a number of journals are starting to provide more fine-grained ways of being able to apportion credit, but I don't think this has yet trickled down to the citation mechanism yet for works that are being referenced. And I think a big challenge, which echoes, I think, things that Ankur and actually like Ankur, Melissa, and Gus have mentioned, is that all of these things make it harder for the authors. And the harder you make it for the authors, the more likely they are not to do anything about it. So I think it's a balancing act. It would be great to get better granularity of roles, but I think we need to solve people actually citing things first. And authorship is probably one of the hardest things to solve.
Certainly in agreement. If anybody, we do have some time for questions. If anybody wants to put up their hand, they're welcome to do that. And yes, we will save the chat and put it in our Zenodo archive as soon as we're finished. There has been quite a conversation on the leap between software citation and reproducibility. We did not specifically have that as a topic today, but of course they're somewhat and greatly intertwined. And I'm wondering if any of our panelists would like to speak to that.
I would, just to pick up on the conversation about notebooks, right? Because it reminds me of the conversation about Docker images, so that reproducibility, and that is that unless you do something, unless authors or developers do something significant, they're impenetrable in terms of transitive credit, right? They're not, like, you can claim that you can, walk the import statement in the first block, but like without someone putting in effort to create a citation list for a notebook, we're not trying to emulate journals here. We're just trying to granularize the material so it can be captured. I think it's a challenge to, and we talked about this a little bit by email, to ensure that a notebook properly cites. I mean, I have done this a few times where people give me a notebook and they're like, let's add this somewhere, and you're like, well, so now that object should cite all the related software objects. It should like all the data objects. Are you ready for that? Do we have a system for that? Do we have a process for that? So I don't know if that's a fork, but I think that's where the conversation gets interesting. But that's my perspective.
I would agree that we're really much even earlier in the conversation than we are with just a software package. And I think Chris shared actually the Google Doc where we have our current version of AGU's notebook guidance. In case anybody wants to weigh in on that, you're welcome to do so. It's currently in circulation with the broader community and growing. So you're all welcome to jump in. Laurent is our editor-in-chief for JGR Planets. Laurent, I'm wondering if you want to come off mute and talk about the culture change some more.
Sure, I can do some of that, because to me this is, and I totally agree with Ankur, that this is really where the issue is. And I mean, I've heard a few things here that kind of made me say, yeah, that's not going to be so easy, because like, I've had cases, for example, of people, young people who refuse to put out their code because they said, well, I've been working a lot on it. I don't want people to take advantage of it. So that's really a matter of attribution. Until we have a citation system that is as well valued as the publications. I'm not talking, I mean, in my discipline, we usually apply codes. We don't develop them as much, but when somebody actually does develop it, they're like, I'm not going to get full credit for that. One thing that kind of bothered me a little bit, I was hearing like things like, okay, the publisher is going to have like boilerplate statements, or it's going to take the code and things like this. The problem with that is it loses the personal touch. And I can see some people feeling like, well, this is not my community wanting it. It's like something that comes out from the publisher and I don't really want to follow it. So I think it's important, speaking on as an editor, I think it's very important for the editors to actually personalize the messages and actually find out what is possible. I think there were some discussions. So I really have a lot of problems to follow chats while people are speaking. But I think there was a bit of discussions about that remaining flexible. I think the boilerplate is helpful as starting point, but it's important to keep the personal touch to customize our response, try to convince people that they need to change the culture.
Yeah, Melissa, I know that the discussion within eLife on software, using software heritage as a mechanism was lengthy. And it was done at a time that was actually fairly progressive within the journal community. I don't know if you want to talk to that a little bit.
Yeah, well, also just responding to the kind of comment about boilerplate. No, I totally agree. And it is very difficult because you're trying to kind of push the boundaries on one side, and putting the effort in, but with non-experts. So, listening to everybody else on this call, it's like, I don't know what I'm talking about, but, I'm trying to do the best in that area. So starting off with boilerplate, but then when you do get the responses back from the authors, then I know it does become more personal within the editorial team. Yeah, with software heritage, it is difficult because with a publishing background, I was like, yeah, Zenodo, you get the DOI and that's great. And it was our head of product who has not got a background in publishing, has not got all of that legacy that we have with citations and who was like, but this is crazy. You're forcing them to do something, package it up and put it somewhere else to get a DOI, and a DOI is a publisher thing. So that's why it was felt much more comfortable going down the software heritage route. And I think there was a question about people only going to software heritage, but you can go back to the code and see it. So yeah, I feel I'm out of my comfort zone because I'm kind of a process person and you know, trying to do the best that we can within the expertise that we have. And also the other issue is the editors. You know, they don't have huge amounts of time to be reviewing all of this stuff. So I mean, we are looking with other groups to think about the idea of reviewing code. So again, that's pretty progressive within publishing, because if you don't have the expertise there, how do you resource that? So, and again, we would be relying on the younger community and early career researchers that are really into the open science to try and get that going. But yeah. Shelley said it's very complicated and very difficult, especially if you don't know what you're talking about.
Yeah, I mean, what I was saying about the younger people not wanting necessarily, some at least not wanting to have their code out. I think this is also part of the culture that is imparted by their supervisor, by saying, oh, you're working on this, you got to get maximum benefit before anybody else gets to see it and gets to play with it or modify it. So that's yes. I don't want to say that young people wouldn't want to do it. Maybe advised not to, in which case it's again a problem with the older.
Yeah, I totally get that. And I think the other difference with eLife though is that if people are going to eLife anyway, they're looking for that kind of different experience and the push on that side of things anyway. So they should naturally, you'd hope, be more open to that. But I totally agree, because you know, there has been criticism of some of our editors that are very well set up in their field and they've already done very well, saying, oh, you don't want an impact factor, what are you talking about? It's like, well, it's all very well for you because you're at that point in your career, but I'm not. So I totally appreciate how it's difficult for early career researchers in many ways.
So it sounds like I see Neil and Ankur, but I'm also realizing that I'm going to need to transition over to Dan here for a second. Ankur, do you want to go quickly, and then Neil, and then we'll send back?
Yeah, I mean, I just wanted to bring up a point that, you know, sometimes too, like, you know, it's easy to somewhat overanalyze some of these challenges too. And I totally agree, like the personal touch can matter a lot. You know, we do that a lot for decision letters and things. There's some things that are can be sometimes be solved with technology, right? Where there may be, like, for example, the fact that now there's a single checkbox for a lot of journals to automatically publish your preprint is increased the probability that I would publish a preprint by a factor of infinity. And the same thing can happen with, like, if it was easy to do something, right? Like scientists, we have a lot and we're lazy people. We like to solve problems that make our lives easier, right? That's what we do for a living. And so there's kind of that sense, like, you know, I finally filed my taxes this morning, and it asked these questions like, you already know the answer to this question. I already like gave you that information 2 years ago. You know, if only there was, and so there are some back end changes, I think, that sometimes can make a big impact, even though they're little.
Yeah, and the difference between that evolving development environment, like a GitHub can provide you, versus the preservation static version that a journal is looking for. And can we possibly navigate that so that we're not asking for the Zenodo version of GitHub? And let's see, Neil, you had your hand up next.
Yeah, and it's kind of following on from that. I do feel like the major challenges we have in trying to gain adoption and making basically journal editors' lives easier is that people are driven by fear and by basically not having enough time. So making things easier and persuading people that they have less to fear is the way to achieving that culture change. And I think one of the things that we often sort of forget is that in many cases around the sorts of papers we're talking about, these will be papers where we're not asking the authors to reveal their code early, because we're asking them to reveal their code at the time of the publication of the paper. And all we're trying to do is make it as easy as possible for them to cite all of the pieces of software that have also been used around the small amount of additional software that they've created as part of that research. So I think there's probably a set of use cases which it's more important for us to be able to support and support the authors with, because those are the ones which are most likely to get people changing their behaviors if we make it easy, because there's less to fear from doing it at that point. There are a whole load of other scary edge cases, which I think will be much harder, but I would say, like, let's start with the easier ones where a small amount of extra help will make authors much more likely to change their behavior.
Gus, do you have a 30-second one, or I see you took
30-second one, and that is that, like, I'm not convinced that the technology stuff works. So the whole point of this, the entire Asclepias project, was that technology will make people's lives easier. And I hate the GitHub designator workflow, right? It creates bad metadata all the time. No one's curating it, and so it's bad. And like Melissa mentioned, authors on GitHub with no license, like, you can't do it without ignoring that step. So what is it about this, like, the sociological problem that, like, I can just skip the licensing step when GitHub practically makes it impossible, or I don't care about authorship. I'm making this thing for authorship purposes, but I don't curate the authorship. So, like, there's something else going on here that's weird. That's my comment.
That great segue over to Dan. So
thanks. So just to wrap up, I guess first I just wanted to say thank you to everybody for participating. If anybody has any comments, please let Neil or Shelley or I know, and we'll try to improve things for a future time. And then also, just if you have a chance, it would be great if you could put in some comment into menti.com and this number once again. And we're really curious from your view as having some role in journals or publishers, kind of what do we need to do that we're not doing? Like, what's keeping you from implementing software citation today? And so I will leave this up. And if people type in answers, we should see them, hopefully. And we'll let this go for a minute or two and see what happens. As I put in the chat notes, the slides and the poll results and the chat data information will be placed onto that DOI. Maybe in a few hours, certainly within 24 hours.
yeah, later today, promise.
Hopefully later today. So I'm not sure if people that are answering this at this point are answering it as authors or answering it as with a role of the journal. I mean, I think we're really more curious about the roles of people that are, I don't know, involved in publication. Like, I don't know, as the editor of a journal or something like that, what do you need in order to implement something for your journal, as opposed to what do you need to do something for your paper?
We do have folks from a variety of backgrounds. Just taking a quick look at who's still online. Repository community, library community. So I think it would be different, definitely seeing from different points of view.
One that I've seen that's really interesting is there's a number of people who've put in just not knowing what is the right software to cite or how to create that citation. So I think that's a really good point, in that if authors are unclear about how to cite or what to cite, then obviously it becomes difficult for them to cite. And there's a question about how journals can and journal editors can help this, given the amounts of time that journal editors have to be able to provide that sort of assistance.
So we're right at time. And I guess I just want to thank everybody for participating again. Neil or Shelley, if either of you have any final comments, please go ahead, and then we'll wrap things up.
Thank you all for coming.
Thank you.
Okay, then thanks everybody. And we'll stop.